Hello, good afternoon, everybody. I think let's start now. Let's not think any much. All right. So first of all, a small poll. If my voice and my video is visible to you, please tell me the status quickly. All right. Thank you so much. So my voice and my video is visible to you, almost everybody. Got it? So now, in the last class, we have discussed about the continuity of a function. And we all are aware when the continuity exists, that means left hand limit should be equal to right hand limit, should be equal to the value of the function at that point. Isn't it? This is what we have discussed, that left hand limit should be equal to right hand limit, should be equal to the value of the function, and that should be a finite known quantity. All right. So today we are going to talk about the differentiability of a function. We are going to talk about the differentiability of a function. All right. So it is differentiability. Differentiability. Now, first of all, a very simple and straightforward meaning that what is differentiability. Got it? So the simple meaning is, say this is a curve. Are you able to draw a tangent on this curve at this point? The plain answer is yes. Got it? The plain answer is yes. Now, say function is something like this. Are you able to draw a unique tangent on it? Are we able to draw any tangent on it? So because of this sharp corner, no tangent. Got it? These are very basic meanings, which we can make it to understand to any layman. So it's a total layman language meanings. So while in any curve there is a sharp corner, we cannot draw a tangent to it. We call it non-derivable at this point. Here we call it derivable at this point. Got it? Now, there is another case, like a curve is something like this. Something like this, where we are able to draw a tangent, but tangent is of infinite slope. Got it? We are able to draw a tangent, but that is of infinite slope. Again, we call it point of non-differentiability. Got it? Point of non-differentiability. And one last meaning, if a curve is simply like this, we'll say like this, which is not continuous. So not continuous means non-differentiable. derivable. Am I clear? So these are the very much simple meanings. So the simple meaning of differentiability is if on a curve at a given point, you are able to draw a tangent of finite slope. If on a curve at a given point, if you are able to draw a tangent having finite slope, we call that point as point of differentiability. Am I clear? Point of differentiability. Now, let us get into the total basic thing about the differentiability. Say this is the graph of a function. This is the graph of a function y equals to fx. Got it? There is a point a comma f of a. In the neighborhood of this, there is a point a plus h, f of a plus h. Now, if I join these points like this, what do I get? I get a chord of the function. Chord. Now, if you make a right angle triangle out of it, and this angle is theta. Say this point is A, this point is B. Now, slope of chord AB will be tan theta equals to, now this length will be what? F of A plus H minus F of A. Am I clear? This length is going to be F of A plus H minus F of A, and this length is going to be H. So tan theta is what? F of A plus H minus F of A upon H. This is the slope of the chord. Now, if this B approaches to A, B is in the right of A, so B approaches to A. In that case, chord AB will become tangent at A. Chord AB will become tangent at A. Yes or no? Chord AB will become tangent at A. So slope of chord will become the slope of tangent. That will be what? If limit h approaches to 0. So if B is approaching to A, means h is approaching to 0. Limit h approaches to 0, f of A plus h minus f of A upon h. Got it? This is what we call slope of tangent at A. That is limit h approaches to 0, f of A plus h minus f of A upon h. And this is what we call f dash A plus. This is what we call the derivative of the function from the right of A. So this is what we call right hand derivative. Right hand derivative means f dash A plus is limit h approaches to 0, f of A plus h minus f of A upon h. This is what we call right hand derivative. So right hand derivative is f of A. See, this is the very basic definition. When everything will fail, only this will work. Getting my point? So if nothing will work, you will feel problem everywhere. You won't be able to differentiate. This is the only thing that is going to work. F of A plus h minus f of A upon h. Similarly, there is a concept of left hand derivative also. That is f dash A minus. This time, tangent at A, but from the left hand side. So I'm writing this formula directly. That is limit h approaches to 0, f of A minus h minus f of A upon minus h. This is the definition for left hand derivative. Remember this thing. Right hand में it is f of a plus h minus f of a upon h. In the left hand it is f of a minus h minus f of a upon minus h. Got it? So a function is called differentiable if differentiable at x equals to a if left hand derivative is equals to right hand derivative is equals to some finite known quantity. So left hand derivative is right hand derivative is some finite known quantity. Then only we say this function is differentiable at x equals to a. Am I clear? So this is the totally fundamental thing. Got it? Now I'll do a question. I'll do that question using the graph, and I will do that question using the total fundamental definition. Got it? See, the question is check for the differentiability of fx equals to mod sin x at x equals to pi by 2. Check for the differentiability of fx equals to mod sin x at x equals to pi by 2. Got it? Now, how do I do it? See, method 1. If you do it using graph, we all are aware of the graph of mod sin x. This is minus pi by 2, 0, pi by 2. Then from pi by 2, this is 3 pi by 2. From 3 pi by 2, this is 5 pi by 2, and so on and so forth. And now if you realize this point, at x equals to pi by 2, there is a sharp corner. If there is a sharp corner, means this function is not differentiable at x equals to pi by 2. So non-derivable or not differentiable at x equals to pi by 2. Got it? Now, if I try to check it using the fundamental definition, see, fx is given to you as mod sin x. Got it? Oh no, I'm doing it for mod cos x. Sorry, this is mod cos x, not sin x. The graph is of mod cos x, and it is non-derivable at x equals to pi by 2. Now, for mod cos x, let's check it using the fundamental definition. Correct in your notes also. It was mod cos x, not mod sin x. Now, first of all, I will find right hand derivative. That is f dash pi by 2 plus. Limit h approaches to 0. F of pi by 2 plus h minus f of pi by 2 upon h. That is limit h approaches to 0. Now, f of pi by 2 plus h is mod of cos pi by 2 plus h, f of pi by 2 0 upon h. That is limit h approaches to 0. Now, cos pi by 2 plus h is going to be minus of sin h upon h. Am I clear? Now, h is very small positive quantity. So, mod of sin h can be written as limit h approaches to 0, sin h upon h, and this answer is going to be 1. Am I clear? So this is the right hand derivative at x equals to pi by 2. Now let us talk about left-hand derivative. So that is f dash pi by 2 minus. Now according to definition, it is limit h approaches to 0, f of pi by 2 minus h minus f of pi by 2 upon minus h. So f dash pi by 2 minus is limit h approaches to 0. That is mod of cos pi by 2 minus h minus cos pi by 2 is 0 upon minus h. So that is limit h approaches to 0. Cos pi by 2 plus h is mod of sin h upon minus h. That is limit h approaches to 0, sin h upon minus h. And this is sin 0 by 0, which is going to be 1. So answer is what? Minus 1. Am I clear? So that means left hand derivative is not equal to right hand derivative. So function is non-derivable at x equals to pi. Got it? Function is non-derivable at x equals to pi by 2. So this is how we do these things. Am I clear? So if the function is quite complex, these basic definitions always work. Or if you can draw the graph of the function, that is the best. Got it? See once. Now let us assume we have a function fx equals to x square if x is less than 0. It is 3x square if x is greater than or equal to 0, less than 3. And it is x to the power 10 if x is greater than or equals to 3. Say we have this function. They are asking for check for differentiability at x equals to 0 and at x equals to 3. Got it? Check for differentiability at x equals to 0 and x equals to 3. See, sometimes we can directly differentiate the function and give the conclusion. See, f dash 0 minus. See, before 0, the definition of the function is x square. Got it? Definition of function is x square. So it will, if you differentiate it, it will be 2x, and value of 2x at x equals to 0 is what? 0. So left hand derivative is 0. Now f dash 0 plus. Now 0 plus may definition is 3x square. So definition 3x square, derivative of the function will be 6x. So at x equal to 0, this is again going to be 0. That means function is differentiable at x equals to 0 as LHD equals to RHD equals to 0. Got it? Now at 3, if we check f dash 3 minus. Now see, before 3 minus, this is the definition. So its derivative is going to be 6x. So 6x at x equals to 3 is 18. Now f dash 3 plus. In the right of 3, this is the definition. Got it? This is the definition. Derivative will be 10 x to the power 9. and this value at x equals to 3 is 10 times 3 to the power 9. So since now here left hand derivative which is equal to 18 is not equal to right hand derivative which is very large, that is 10 times 3 to the power 9. So what do you directly say? Function is non-derivable at x equals to 3. Got it? Function is non-derivable at x equals to 3. Now see, one thing we can judge directly here. Before 3, value of the function is what? 3 cube. Before 3, value of the function is what? 3 cube. And after 3, value of the function is what? 3 to the power 10. Am I clear? So since there is no continuity, so there is no question of differentiability, we can directly give the conclusion based on the continuity also. Now see, let's do certain points, important points. If fx is differentiable at x equals to a. So if fx is differentiable at x equals to a, that means it is continuous at x equals to a. Got it? So if a function is differentiable at x equals to a, that means it is continuous at x equals to a. Okay, one thing I would like to mention. We just found f dash 3 minus is 18 here. What if I try to do it using the basic definition? Let's discuss this one thing also. F dash 3 minus is limit h approaches to 0, f of 3 minus h minus f of 3 upon minus h. That is limit h approaches to 0. F of 3 minus h is what? 3 minus h 3 times 3 minus h whole square minus f of 3. F of 3 will be 3 to the power 10 upon h. Got it? If you see as h approaches to 0, denominator is 0, but the numerator is non-zero. So this value goes infinite. Got it? Whereas from this definition, we are getting left-hand derivative as minus 18. So in general, these things are having flaws, but this definition is completely flawless. We are getting the same answer, so at times we do not notice these things. Got it? But this is totally correct, and this is a flaw. So, because what did I do? I differentiated a function in the left, which is actually non-differentiable. So these methods are not safe sometimes, but most of the time they works. Got it? Now, if fx is differentiable at x equals to a, that means it is continuous at x equals to a. Fair enough? Second point, if, okay, its converse is not true. Is not true. Means if a function is continuous at x equals to a, that does not mean that it will be differentiable also at x equals to a. Clear? Now, if fx is non-differentiable at x equals to a, and the reason for non-differentiability are reason for non-differentiability is different but finite LHD and RHD. That means function is non-derivable, that is fine. But the reason for non-differentiability is what? Reason for non-differentiability is different but finite left hand and right hand derivative. In that case, this function is continuous at x equals to a, and there will be sharp edge at this point. And if there will be sharp edge, that means it is non-differentiable. Got it? Now, a few questions, let's start. Check for the differentiability. Differentiability of the following. First is fx equals to sine x at x equals to 0. Second, fx equals to sine square x at x equals to 0. Third, fx equals to mod sine x at x equals to 0. And fourth, fx is under root of sine x at x equals to 0. Got it? Now see, graph I will use. Got it? This is the graph of sine x in minus 2 pi to 2 pi, minus pi to pi, minus pi, 0, pi. This is the graph of sine x, and it is completely derivable at x equals to 0. Got it? Now, if I try to draw the graph of sine square x, see, this was the graph of sine x. Now, if I want to draw its square, means the values which lie between 0 to 1 will decrease. So, graph will be something like this. Like this. And if you realize, there is a smooth edge at x equals to 0. So, both of them, they are differentiable at x equals to 0. If I try to draw the graph of mod sine x, graph of mod sine x will be like this. Am I clear? And definitely there is a sharp edge. There is a sharp edge. That means what? Non-differentiable at x equals to 0. If I try to draw the graph of under root of sine x. Now see again. This is the graph of sine x. You are taking the under root of values which are between 0 to 1. This is the graph of mod sine x. So you are trying to take the under root. Let's do it mod sine x. So you are trying to take the under root of the values which are already lying between 0 to 1. So these values will increase after taking the under root. So graph will be something like this. Like this. 1 will remain 1, 0 will remain 0. But in between the values will increase. And from the left hand side also it will be something like this. And now you realize this is a sharp point. So non-differentiable at x equals to 0. Got it? Now another function fx equals to x to the power 1 by 3 at x equals to 0. Now what is happening if I try to draw the graph of x to the power 1 by 3? Graph will be something like this. Like this. If you realize this slope of tangent at x equals to 0 is infinite. There is a vertical tangent. So slope of tangent is infinite means what? Point of non-differentiability. Slope of tangent is infinite, so it is the point of non-differentiability. Am I clear? Now, let's do a very popular and important question. A function fx is given as x sine 1 by x while x is non-zero and it is 0 if x is 0. So I'm asking you for check for continuity and differentiation. See, for such kind of functions, checking differentiability for such kind of functions, checking differentiability using basic definition is always recommended and suggested. Because if you try to check the differentiability using differentiation or any other method, you always get the wrong answer. Now, first of all, for the continuity. So f of 0 plus is what? Limit h approaches to 0, f of 0 plus h. That is limit h approaches to 0, h sine 1 by h. 1 by h. Now in the previous class also I told you this value is lying somewhere between -1 to 1 and outside h will make it 0. So this answer is going to be 0. Similarly, if you check for f of 0 minus, it will be limit h approaches to 0, f of 0 minus h. That is limit h approaches to 0 minus h minus 1 by h. So this value is again going to be 0 for the same reason. Am I clear? So that means what? It is continuous and f of 0 is given to you as 0. So it is continuous at x equals to 0. Got it? Now if we want to check about its differentiability, see f dash 0 plus limit h approaches to 0 upon h. That is limit h approaches to 0, h sine 1 by h minus 0 upon h. This h cancel. So you are left with limit h approaches to 0, sine 1 by h. And we have no idea. We have no idea about the value of sine 1 by h if h approaches to 0. We only have an idea that it is somewhere between -1 to 1. But what it is, we have no idea. And since we have no idea, we will say it as a point of non-differentiability, because even if you check for left-hand derivative, f dash 0 minus, it is limit h approaches to 0, f of 0 minus h minus f of 0 upon minus h. That is limit h approaches to 0, it will be again sine of 1 by h. Am I clear? So both of them, f dash 0 plus f dash 0 minus, whatever their values are, we have no idea. We only have idea it lies between -1 to 1, but no idea about exact value. So this is what? Point of non-differentiability. This is what I call point of non-differentiability. Very, very important question. Now I give you a question for your trial. See, if we frame a question like fx equals to, it is x square sine 1 by x if x is non-zero, and it is 0 if x is 0. It will be continuous and differentiable both at x equals to 0. Continuity में both left hand and right hand limit will come to 0. Differentiability also, left hand derivative and right hand derivative both will come to 0. Got it? So you are going to do it on your own. Now, few points. Differentiability at x equals to a implies continuity at x equals to a. We have just done it, but continuity at x equals to a does not imply differentiability at x equals to a. Am I clear? Next point. Non-differentiability at x equals to a does not imply discontinuity at x equals to a. But discontinuity at x equals to a certainly implies non-differentiability at x equals to a. Got it? Now see. Just a moment. Now, let us do this question. Question number 5. Fx is given as ax square minus b if x lies between -1 to 1, and it is -1 by mod x if mod x is more than or equals to 1. All right. So first of all, let us redefine this question. So if x lies between -1 to 1, it is ax square minus b. If x is more than 1 or equal to 1, mod x will be plus x, so it is -1 by x. If x is less than or equals to -1, mod x will be minus x. So now it is 1 by x. Got it? So they are saying it is differentiable at x equals to 1. So if this function is differentiable at x equals to 1, find the values of a and b. So certainly, if it is differentiable at x equals to 1, that means it is continuous also at x equals to 1. Means f of 1 minus is going to be f of 1 plus. So value in the right of 1 is minus 1 and value in the left of 1 will be a minus b. So you got one relation in a and b. Am I clear? Now, for differentiability, f dash 1 plus. That is, see, in the right of 1, derivative of minus 1 by x is going to be 1 by x square. At x equals to 1, it will be 1. Am I clear? Now, f dash 1 minus. In the left of 1, derivative is going to be 2ax. So it is going to be 2a. So since it is differentiable at x equals to 1, so 2a is 1, a came 1 by. Now put the value of a, b came 3 by. I hope I have made my point very clear. Got it? Now, there are a few more questions. You can take a screenshot if possible. Please try them later on. Now, see. Fx equals to, say they ask you ln x mod at x equals to 1. Check the differentiability. So, very simple, I know. This is the graph of log x. This is the graph of log x. Now, if you take mod of this, so the portion which is below x-axis will have a reflection above x-axis. So the graph will be like this. Got it? This point is what? 1, 0. And it is very much clear that there is a sharp corner at this point. So x equals to 1 is point of non-differentiability. Got it? Now see another function if I see fx is mod of x square minus 3x plus 2. Now they are asking for the points of non-differentiability for this function. Do you realize it is mod of x minus 1 into x minus 2? See, a quadratic with roots as 1 and 2 will be something like this. A quadratic with roots as 1 and 2 is something like this. Now you take mod of this fx. Taking mod means portion below x-axis will shift above x-axis. This will go this side and this will go this side. So it's very much clear that there are 2 points of non-differentiability, 1 and 2. Yes or no? So there will be 2 points of non-differentiability. See, whenever mod comes there, that is highly probable. That is highly probable that the non-differentiability occurs. We still do not guarantee it, but yes, there is high probability. Now, a function again, I'm giving you fx is e to the power minus mod x. Now, what it is? If x is greater than 0, it is e to the power minus x. If x is less than 0, then it is e to the power x. The graph of this function is going to be something like this. This and this. And you again see there is a sharp corner at 0, 1. So means what? Non-derivable at x equals to 0. non-derivable at x equals to 0. All right. So let's go. I'm going to tell you a different type of function which you might not be aware of. Say fx is given as maximum of 1 minus x, 1 plus x, and 2. Fx is given as maximum of 1 minus x, 1 plus x, and 2. Fx is 1 minus x, 1 plus x, and 2. They are asking for counterpoint of non-differentiability. First of all, how do we draw these functions? See, this is a blend of three functions. Y is 1 minus x, y is 1 plus x, and then y equals to 2. First of all, on the same coordinate plane, we are going to draw these three lines. So y equals to 1 minus x is basically x plus y equals to 1. So this is going to be this line. Am I clear? Now, y equals to 1 plus x is again a line with y-intercept as 1 and slope is also as 1. So it is going to be this line. Got it? And now there is a line y equals to 2. There is this line y equals to. Now see what they are saying. They are saying maximum of this. Maximum of this means if you realize in this region, in the right of this is the maximum among all three graphs. Before this is going to be the maximum. And before this is going to be the maximum. So for any individual x, this is going to be the graph of this function. Yes or no? All right. So if this is the graph and you clearly see that this point, you can clearly see that this point and this point are two sharp corners in this graph. This point and this point are two sharp corners in this graph. So 2 points of non-differentiability. Two points of non-differentiability. You just draw the graph and for individual x, check where the function is maximum. That will be your part of the function. Got it? One last question I will take. Fx is ax plus b if x is less than or equals to -1. And it is ax square plus x plus 2b if x is more than -1. They are saying it is differentiable for every x belongs to R. Then find a and b. Got it? See, this function is already derivable everywhere if the problem occurs that may occur at x equals to -1. Because in the left of -1, it is linear polynomial that will be derivable. In the right of -1, it is a quadratic polynomial that will also be derivable. So if there occurs any problem, that problem will occur at x equals to -1. So first of all, I'll check the continuity. F of 1 minus should be equal to f of 1 plus. F of 1 minus will be minus a plus b. F of 1 plus will be a minus 1. Minus 1 plus. So it is a minus 1 plus 2b. Got it? So from there I get 2a plus b equals to 1. One equation you got. Am I clear? Now, f dash minus 1 minus. In the left of 1, derivative is a. So that will remain a. F dash minus 1 plus. In the right of 1, derivative is going to be 2ax plus 1 at x equals to -1. So it is minus 2a plus 1. Now since it is differentiable also, so minus 2a plus 1 is equals to a. So 3a equals to 1, a comes 1 by 3. You put value of a here, you get B as 1 minus 2 by 3. That is also 1 by 3. All right. So this was all about differentiability. As such to you, you all are aware that no topic in maths ends ever. There are infinite possibilities of question. So now, but I think I've made you capable that you can attempt questions from any source that you are having along. All right. So this was all about differentiability and continuity. Practice more. That will be the only gateway to IITs or say any other premium NITs. Got it? Now I would like to ask you about the feedback of the class. Please give your genuine reply. Just a moment. I think there is some problem with the poll. All right, that is fine. Just a minute, just a minute. Yeah, now please give your feedback for the class. Thank you so much.